Hello everyone. In this video, we're going to talk about lesson 11. Okay, and lesson 11 is called ANOVA. ANOVA, A-N-O-V-A, and you pronounce that ANOVA. This is the last lesson in our whole course, so you've made it to the last lesson. You've only got a couple more videos to go. Okay, so in lesson 9, we talked about confidence intervals and hypothesis test for one mean, mu. Okay, and so we could do a confidence interval, we could do a hypothesis test for one mean, but what if I have more than one mean? Okay, what if I have more than one group? So maybe I want to compare different groups. So a question that I might be interested in is who on campus has on average the highest GPAs? Freshmen, sophomore, juniors, or seniors? Okay. And so if I wanted to answer that question, I'd probably want to do some sort of inference like we did in chapter 9. But I have 4 groups instead of 1. And the methods that we did in chapter 9 only do one group. So we need another method that lets us compare more than one group. Again, I'm sorry about my dog. He's playing with a toy now. So if you hear squeaking, that's him. Now, as we'll see in the next slides, the ANOVA is the method that's going to help us do that. I first have a small motivating example that helps us to understand what the ANOVA is looking at, okay, or what the ANOVA is really doing behind the scenes. Hopefully this example won't confuse you too much, and actually hopefully it'll make things a little easier to understand. So my motivating example is this. I want to see whether the tar contents in milligrams for whether the tar contents in milligrams for 3 different brands of cigarettes is different. Okay, so I would definitely not smoke at all, and that's just my choice. Okay, but maybe I'm interested in which one has the least amount of tar, because of course, if you think about tar going into your lungs, that's not a happy thought. Okay. Or maybe I'm testing to see whether these companies who make the cigarettes are actually abiding by standards set forth, or are they sort of bending the rules? Okay. So to this end, to test my claim above, I have 2 different labs come in. Okay, because one may not be enough. I'd like to see 2 of them get the same exact answer. That would make me feel better. Okay, one, there could be some sort of slip up, but the likelihood that 2 labs get the exact same results, which are untrue, is very small. Okay, so I take 6 measurements from each of the 3 brands. So I look at 6 different cigarettes from each of the 3 brands, and so here is the data. So you're going to see this. This is going to be in a different format than what we're used to. Okay, this is actually in another sort of statistical software called R. Okay, this is actually what I use in my daily work. Okay, so here are the 6 measurements from that first lab, which we're going to call precise. Okay, and this is the better lab. And then we have the same measurements on the same sort of in the same sort of cigarettes. Okay, for each of the 3 brands, A, B, and C. And your first thought about these brands, how can I tell the difference? What my first thought should be probably is, what do the means for each sample look like? Okay, so if I took the mean of brand A, brand B, and brand C, and they were all the same, okay, then it's probably likely that they aren't different. Okay, the means aren't different if the sample means, i.e. the means of these 6 numbers, are the same. But if they're different, then that's a different story. Okay? So I take the means of each of them, and I find that for each lab, the mean for A was 10, the mean for B was 11, and then the mean for C was 12. And so I'm starting off very well. Both labs are telling me the exact same story, that there's a 1 milligram difference between A and B, and then B and C, okay, for each of them. But of course, I also know that this is just a sample and that things can behave differently from sample to sample. So I can't take this as sort of the word of truth or the whole truth. Okay, it's just part of what we need to think about. So let's take a look at actual plots of them and see if they still say the same story. Okay, so these are the measurements from Lab Precise, brands A, B, and C. Okay, and I'm still looking for a difference. Okay, does it seem like there is a difference? And so your impression from this picture is probably yes, there definitely is a difference. Okay, A definitely looks different from B, which definitely looks different from C. Okay, great. Here is Lab Sloppy. Okay, so remember that between the labs, the means were the same. Okay, so if I took the means of these 6 numbers and I plotted them, okay, they would be the same for Lab Sloppy as they were for Lab Precise. But now we're looking at the whole picture in some sense, right? And I would ask you in class, do these plots tell the same story as the one from Lab Precise? Or do they tell a different story? Okay, and I'll just make believe that you gave me the exact answer that I wanted. And the answer is no, they don't give the same story. Okay? In Lab Sloppy, I'll go back. In Lab Precise, here, there's absolutely no overlap in the dots between each group. Okay, all of Group A's dots are below all of Group B's dots, which are all below all of Group C's dots. But in Lab Sloppy, in this picture, there's a lot of overlap. And on top of that, we know that this is only one sample, not many samples. Okay, this is only one sample out of a bunch of them, so this doesn't tell us the whole story. Okay, we understand, or we hopefully understand, that when I take another sample, these numbers are going to be different, and they'll tell me maybe a different story. Okay, so the overarching takeaway here is that this picture tells a much less motivating or much less clear story, okay, a much weaker story than this one. Okay, in this one there's no doubting it. The groups are different. In this picture, you say, well, it sort of looks like C is above B, which is above A, but the picture is a little bit more murky. All right, and so that's the motivating example. I know it didn't give you some clear answer to everything, but it does tell us a few important things that we'll see in the next slide. So, in the ANOVA method that we're going to talk about in just a second, variation is important. Okay, in fact, it's the most important thing that we do. There are 2 types of variation that we're interested in when we're looking at a problem with the ANOVA method. Okay, the first is how different the group means are. All right. And so that's what I showed in sort of the first slide, okay, when I saw that the group means were 10, 11, and 12 for each lab. Okay. So that's important. Okay. So where each of the groups, or where each of the samples are average, okay, where the average of each sample lies, okay, is important, okay, and the differences between those, we're going to call that between group variation, is important. But there's another type of variation that's also important. And that variation is how spread out each of the groups are. Like by themselves, not comparing any other group, just the one sample that I got. Okay? That's called within group variation. If the group differences are large compared to the variation within each group, then there's likely a difference. And where does that manifest itself, or where have we seen that before? That's the lab precise picture. Okay, there was clearly a difference because there was the differences in group means were much larger than the differences in each group. Okay, basically meaning that there was no overlap. Okay, and so there was likely a difference. But if the group differences are small compared to the variation within each group, then it's less clear that there is a difference, and that's the story told in the lab sloppy picture. Okay. It had the same group between group difference as lab precise, but the variation within each group was much larger, and so it was a less clear picture about what was happening or if there was a difference between those groups. So that leads us to the actual one-way ANOVA hypothesis test that we're going to do. All right, so I'll stop the video here and we'll go into that in the next section.